All right. So the question says an evacuated chamber contains a pair of parallel plates connected to a power supply and a switch which is initially closed. A positively charged mass falls within the chamber under the influence of gravity from the position shown. When the mass has fallen half the height of the chamber, the switch is opened. Which of the following correctly shows the trajectory of the mass? Okay, so let's start putting the things in the picture. So this is the battery, positive and negative DC supply. So this plate will be negatively charged and this plate will be positively charged. And then it says this is the mass M. And so we have the mass M, which is also positively charged. So if I can put over here. Now the question also says evacuated chamber. So what does that mean? So this chamber has a vacuum, so which means there is no air, and therefore there is no air resistance to the falling object. So that force is not to be considered. So let's see what are the forces that will act on this object. So there will be a force due to the gravitation, and that force will be given by Fg is equal to mass into acceleration, which is mg, and mass is constant, g is constant, and therefore the force due to gravitation is constant. And then there will be one more force, that's because of the electric field between the two plates. So maybe I can draw it. Maybe it's not a very smooth drawing, but let's see how best I can draw. So there will be a force due to the electric field, Fe, and that will be given by Q times E. The force will be that the particle or the object will try to move towards the right hand side because the right hand side plate is negatively charged. And if you remember, what is the value of E with respect to the given question? So it will be V divided by D. So the charge is constant, the potential difference between the plates is constant, and also the distance D between the plates is constant. Therefore, the electric force is also constant. So we have two perpendicular forces. So the resultant force will be the resultant of the two forces, yeah, and it could be at some angle depending on whichever force is higher. So maybe I take a example just for understanding that this is at 45 degree, but one thing for sure, it will be a straight line. Yeah, it could be inclined towards the electric force if the magnitude of electric force is higher than the gravitational force, and vice versa. But definitely it will be a straight line. So the moment we have this confirmation, so options C and D are ruled out. Why? Because they are showing the curve, and D also shows curve. So which is not possible because it has to be a straight line. So we see that till the point maybe H, if I can put over here, the particle will follow the straight line. And what happens at H? We are switching off the switch. So the switch will be put off. Therefore, the circuit is open, and therefore there will be no electric force. So from this point onwards, the force due to electric field will be equal to 0 because there is no electric field, and therefore the force that will be existing on the that will be applied on the particle will be force due to gravity. And therefore from this point onwards only the vertical component is there. But hold on, there will be, till the time it has reached the point H, there will be some, just before reaching H, it would have acquired some horizontal component of the velocity because of the electric field. Of course, that due to inertia, it will hold on to that velocity, horizontal velocity, but over a period of time, it will go down. And therefore, the path is expected to be something like this, it will be kind of a parabolic path. Yeah, it's not very clearly shown over here, but let's see what are the options we have. So A and B till this point are okay, they are following the straight line, so this is fine. But option B certainly is ruled out. Why? That's because this would have been the case if there was a certain same value of electric field, if that was existing. If the switch was not made open, then this option B would have been the correct one. But in our case, we have the switch open, and therefore the path will be something like this, and therefore option A is correct. I wanted to explain a bit about the horizontal component of the velocity that it has acquired when it just reached at this point by virtue of the inertia. So it has this component, and now after this time, since there is no electric field, so this component will gradually reduce, go on reducing, go on reducing. Ultimately, at this point, the horizontal component will be 0 when it hits the bottommost position. But if you see the vertical component will still remain the same at all the points. Yeah. So up till the point H, it will be a straight line, and after the point H until it hits the bottom, it will be a parabolic path. So option A definitely is the correct one.